Imagine a single photon, a tiny particle of light. It has been traveling for an unimaginably long time. It left its star before humans ever walked the Earth. It journeyed through the cold, dark void, past swirling nebulas and sleeping galaxies. It dodged the immense gravity of black holes and sailed through empty expanses wider than our minds can hold. This little messenger has been on its journey for millions, maybe even billions of years. We have words for big. A mountain is big. An ocean is big. The Earth itself is enormous, a giant sphere of rock and water that dwarfs everything we know in our daily lives. We can fly for hours and still only see a fraction of its surface. We think we understand this scale. But when we turn our gaze from our world to the cosmos, our definitions begin to crumble. Imagine our sun, the center of our solar system. It's 1,000,000 times larger than the Earth. If our planet were the size of a tiny pebble, the sun would be a glowing sphere about 5 feet tall. Now on this scale, where is the next star? On this scale, the nearest star, Proxima Centauri, would be another pebble located about 2,000 miles away. Within this vastness, a cosmic ballet of creation and destruction unfolds. Here, incredible things are happening on scales we can barely comprehend. Let's travel to the corpse of a giant star. After a massive star exhausts its fuel, it collapses under its own immense gravity in a violent explosion called a supernova, an event so bright it can briefly outshine its entire galaxy. What's left behind can be one of the strangest objects in the universe, a neutron star. Imagine taking a star larger than our sun and crushing it down into a ball no wider than a city, just a dozen miles across. The material in a neutron star is so dense that a single teaspoon of it would weigh billions of tons, like packing an entire mountain into a sugar cube. Due to a principle called the conservation of angular momentum, the same reason a spinning ice skater speeds up when they pull their arms in, these collapsed stars spin at breathtaking speeds. Many neutron stars, which we can detect as pulsars, rotate hundreds of times every single second. But some of these speed demons get an extra kick. If the initial supernova explosion is asymmetrical, it launches the neutron star like a cosmic cannonball. We have tracked these runaways blazing through the Milky Way at over 2 million miles per hour, a stark reminder of the violent and powerful forces shaping our universe. Now let's zoom out, far out, beyond our galaxy, beyond our local group of galaxies. For a long time we imagined galaxies were scattered randomly through space, like marbles tossed onto a floor. But as our maps of the cosmos became more complete, a stunning picture emerged. We call it the cosmic web. It's a gigantic, intricate network of matter across billions of light years. These filaments connect in dense intersections called superclusters, which are home to thousands of galaxies. They are the great highways of the universe, channeling galaxies and gas toward cosmic cities. Between these glowing threads are vast, dark, mostly empty regions, cosmic voids. Tiny quantum fluctuations moments after the Big Bang were stretched by cosmic expansion, and over billions of years gravity pulled matter into denser regions to form filaments and clusters. We have a speed limit in the universe, a very famous one. Albert Einstein taught us that nothing with mass can travel through space faster than the speed of light. But the rule forbids motion through space faster than light. It says nothing about space itself. Imagine 2 dots on a balloon. Inflate the balloon. The distance between them grows. The rubber, the space between them, is stretching. Galaxies aren't flying through space from each other. The fabric of space-time between them is expanding. Edwin Hubble discovered this and changed cosmology. He observed, the farther a galaxy, the faster it appears to recede. That's uniform expansion. That observation pointed to the Big Bang. The universe began in a hot, dense state and has been expanding and cooling ever since. Expansion of space-time is happening now, all around us. The space in your room is expanding, but atomic and chemical forces overwhelm it so you don't notice. On cosmic scales, expansion dominates. Here is where our minds truly begin to stretch to their limits. If space itself can expand, how fast can it go? Is it also bound by the speed of light? The astonishing answer is no. There is no known limit to how fast the fabric of space-time can expand, because the speed depends on how much space lies between us and a distant galaxy. Something incredible happens at great distances. There's a point where the space between us and a distant galaxy is carried away faster than light. The light from that galaxy, even though it's traveling toward us at the speed of light, is like a swimmer trying to cross a river that's flowing faster than they can swim. The light is moving toward us, but the space it has to cross is expanding so quickly that the total distance is still increasing. The light will never reach us. It is lost to us forever. This creates a boundary around us called the cosmic horizon, the edge of the observable universe. So, we live inside a cosmic bubble, our observable universe. It's a boundary not of substance, but of information. This bubble is defined by the distance light has been able to travel to us since the Big Bang, about 13.8 billion years ago. You might logically think this means our observable universe should be 13.8 billion light-years in radius. But you'd be forgetting about a crucial cosmic factor: the expansion of space itself. The very fabric of the universe is stretching. The point where that ancient light began its journey has been carried much farther away from us over the eons. Today, that point is about 46.5 billion light-years away from us, making the diameter of our observable universe a staggering 93 billion light-years across. To grasp this scale, imagine our entire Milky Way galaxy were the size of a single grain of sand. The observable universe would then be a sphere larger than a football stadium. Inside that vast stadium are at least 200 billion other grains of sand, each one a galaxy. And each of those galaxies is teeming with its own stars and planets. And that's just the part we can see. It's a humbling realization that our entire cosmic view is just one small illuminated pocket of a much larger, potentially infinite reality. What lies beyond that edge? Our best theories suggest it's simply more universe stretching on and on. We've journeyed from starlight to neutron stars, from cosmic filaments to the expanding fabric of spacetime itself. But what if even that isn't the end of the story? Some of our most advanced theories in physics, string theory, eternal inflation, hint at an even grander possibility. They suggest that our entire universe might be just one bubble among countless others, floating in a higher dimensional space. Each of these universes could be vastly different from our own. They might have different laws of physics, different fundamental constants, maybe even different numbers of dimensions. Some might be sterile and collapse quickly, others might be richer than our own. If the scale of our own universe is hard to grasp, the scale of a potential multiverse is on another level entirely. The 93 billion light-year observable universe would be just a single, infinitesimal grain of sand on an infinite cosmic beach. It makes all our previous struggles with the word big seem quaint and small. We began our journey by looking at a single point of light in the night sky. We end it here, with a radically new perspective on our place in the universe. A perspective that shifts us from the center of everything to a humble yet profoundly significant vantage point. From hyper-fast dead stars to the endless tapestry of the cosmic web, to the very fabric of space expanding faster than light, reality is far grander than our ancestors could have imagined. We are living in a remarkable time, a brief moment in cosmic history, when a species on one small planet has begun to piece together the story of the whole universe. The atoms in your body were forged in the hearts of stars that died long ago. You are not separate from the universe, you are a part of it. A thinking, feeling, wondering part. You are a way for the cosmos to know itself. So the next time you look up at the night sky, don't just see points of light. See time machines. Each photon a messenger from a distant past. See the vast, invisible structure of the cosmic web stretching between them. Feel the universe expanding, carrying distant galaxies away, and know that even in this immense emptiness, we are not adrift, but connected. Let go of your old earthbound ideas of big. Embrace a new kind of scale, one measured in light-years and cosmic horizons. Let the sheer, mind-boggling immensity of it all wash over you. Be inspired by it. Let it fuel your curiosity. There are still so many questions to ask. The journey has just begun.